Okay, the problem statement goes like this. You are asked to write a program using Java for error detecting code using CRC where they have given 16 bits. Okay, so error detecting code can be done using CRC that you have studied, right? That is cyclic redundancy check algorithm. In this program, they have given CCITT. Okay, this means, this stands for the International Telegraph and Telephone Consultative Committee. See, this committee has given a polynomial standard, that is 16 bits you are supposed to use for this algorithm. Okay, so that is all about this CRC CCITT. I hope I am clear. See, here they have mentioned only 16, particularly 16 bits. Why? Because there are many standards as well while choosing polynomial generator. Okay, so wherein you are supposed to choose the 16-bit polynomial itself. We'll see that thing in the next slides. Okay, basically what is CRC? Obviously, you know, it is used to check errors, right? Errors, that is in the digital networks, or it may be in the storage devices to detect accidental changes to raw data. See, in your syllabus in the previous semester, you have studied to find errors with respect to digital networks. Okay, whereas you can use this method while finding errors in the storage devices as well. In your higher semester, you are going to study the storage area network, wherein we are using CRC over there. That you will study in your 7th semester as an elective subject. So as of now, you just remember this error detecting code is used in digital networks. CRC code is used to find out errors in digital networks. Or you can say here, one second. Yeah, or you can say detecting accidental changes or errors in the communication channel. If I'm sending any data from my end to my friend who is located in somewhere other places, if the data is received at other end is properly received or not. Whether there are errors or the faults are there or not, that we are going to check it using cyclic redundancy check. Okay, and the cyclic redundancy check algorithm uses generator polynomial. Okay, and this generator polynomial is used at sender side as well as receiver side. That means whatever the generator polynomial I'm using in this algorithm, that generator polynomial should be agreed between sender and the receiver. Okay, so the polynomial on which these two parties are agreed upon, that polynomial you are supposed to use to implement the CRC. We'll see that. See, there are many standards polynomial. One is CRC12, CRC16, CRC-ITU, and CRC32. Okay, you can see here the polynomial written is CRC12 means the x power of 12 plus x power of 11 plus x power of 3 plus x plus 1. So there are different polynomial. These are used to implement the CRC. Okay, but according to your syllabus, they have particularly given to follow this polynomial. So I'm going to concentrate on this itself. That is x power of 16 plus x power of 15 plus x power of 2 plus 1. Okay, so this polynomial is used at the sender side as well as receiver side. I hope I'm clear to everyone, right? Yes?
Yes, ma'am.
Okay. So considering this generator polynomial, that is x power of 16 plus x power of 12 plus x power of 5 plus x power of 0. Like this is the standard that we are going to use here. Okay. And this polynomial generator, that is used at the sender side as well as receiver side. So here you can see, I'm just writing this 16, see here, it starts from 16 till 0, right? So that is what I'm writing here, the powers. from 0 to, you can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I'm converting this polynomial into bit string. That means to binary format. So how do you write it? See here, this is x power of 16, right? That means this will be 1. Here there is no x power of 15. That means it is 0. 14, 0. 13, it's 0. At 12, x power of 12, it is there in the polynomial, right? So there it is 1. X power of 11, it's 0. 10, it's 0. 9, it's 0. 8 is 0. At 7 is 0. 6 is 0. And again, x power of 5. That is, at 5 also, it's 1. And 4, it's 0. 3, it's 0. 2, it's 0. And 1 is also 0. And the last term is x power of 0. There you are supposed to write it as 1. So this is the bit binary format for this generator polynomial. I hope I'm clear to everyone. So how many bits are there here in total? There are 17 bits. See, again, I'm telling you, this is the generator polynomial that is given in your syllabus to follow. Okay. And this generator polynomial is represented g of x, and whatever the converted bit string I have written here, I've just summarized here. Okay, I've written in continuously. 1 0 0 0 1 0 0 0 0 0 0 1 0 0 0 0 1. So there are 17 bits when you convert the generator polynomial into binary format. Okay. So this is the basic thing you should understand with respect to CRC implementation. Next, we directly go to the algorithm, like how CRC is implemented first at the sender side. That means when I want to send the message from my end to other end, what is the first step that is involved while preparing the data? Okay, so initially you have to specify the data, that is bit string here. So I'm going to consider the data in the form of binary bits. Okay, so that is the message I want to send it. Okay, and according to the CSC algorithm, we have to append 16 zeros to this bit string. Why 16 0? See, that is the generator polynomial they have mentioned in the question. Okay, that's why I'm considering the 16 zeros here. Okay, or you can say, since it is 17 bits, right? When you convert the polynomial into binary bits, it is 17 bits, right? So you have to append number of zeros to the data that you want to send to other end. Then 17 minus 1, that will be 16, right? So 16 zeros you have to append it to the data string. I hope I'm clear. Initially, consider the data string, which I have written in binary format. For this, you have to append 16 zeros. Why it's only 16 0? Because the polynomial that is mentioned in the question is 16 bits, right? So that's why I have assigned 16 zeros here. This is data that I want to send it, and for this I'm assigning 16 zeros. Okay. Next, 1 second. Divide this data, I mean the new data here, after appending 16 zeros. Okay, divide this b, that is string b, by agreed on polynomial g of x and determine the remainder r of x. That means you have to divide this dividend by the divisor. Which is the divisor here? That is polynomial, that is g of x. This is g of x. This is g of x. That means this you have to consider. Fine. So that is what I have written here. This is g of x and this is string b, where I have appended 16 zeros for the data. Okay. After performing the division operation, whatever the remainder that you will get, that we call it as r of x. That is represented which means it is a remainder, and I'm representing it with R of X. Okay, and this remainder we call it as checksum. Do remember these words. The remainder we call it as checksum. Okay, you have to divide this data with the generator polynomial. Okay, and this division, so that is what I have just given in the points. The message string after, whatever the checksum that you get it, that checksum should be appended to the data. Then this whole thing we call it as CRC. This whole thing we call it as CRC. Do remember. So this is the, see, after performing division operation here, whatever the remainder that you will get, that we call it as checksum. Okay, not the quotient here, but the remainder, that we call it as checksum. This checksum, you have to append it to the data, that is 110. See, initially here, the data that I have considered is 110, right? For that 110, you have to append the checksum. So 110, for this, you have to append the remainder. That will give you CRC, okay? Or you can say CRC code, okay? And this code, whatever the code that you got here, that should be sent to the receiver, okay? Once this code word is received at the receiver, again, the same code word has to be divided by the generator polynomial, which is agreed upon between sender and the receiver. That is the same thing. Again, the received code word should be divided with the help of this g of x. At the sender side also, we are going to perform the division operation. At the receiver side also, we are going to perform the division operation using the same g of x. Okay. So once you perform the division operation, if the remainder is 0, okay, if the remainder is 0, then receiver concludes that there are no errors. Okay. If the remainder is not 0, if you get 1 in the remainder, then that means there is an error. Okay, and it requires retransmission. Okay, I hope I'm clear. Is it clear to everyone? Please respond.
Yes, ma'am.
Okay. So let's see how this division operation is done. Okay. So here, with respect to our CRC, we are going to perform binary division. Okay. That is using XOR operation. Fine. So first, let us see the truth table for XOR operation. So first, I have considered the inputs here. Let AB be the inputs, 2 inputs. When you perform XOR operation on 0, 0, the output will be 0. XOR on 0, 1, output will be 1. XOR on 1, 0, output will be again 1. XOR on 1, 1, the output will be 0. Okay, if the inputs are same, then output will be 0. Okay, here you can see here 0, 0, it's 0. 1, 1, then it is 0. So if inputs are different, 0, 1 or 1, 0, the output will be 1. Okay, so let's perform the division operation. Okay, initially let's consider the data is 110 and dividend is, for this 110, I'm appending 16 zeros. Okay, and the divisor is the generator polynomial that we discussed in the initial slides. This is what? Divisor. Dividend and divisor. Using divisor, you have to divide this dividend. Let's see. Okay, see here. This is divisor or generator polynomial, and this is the dividend. Okay, here binary division is performed with the help of XOR operation, as I said, right? So let's see how it is divided. Using this divisor, this is the divisor, right? Perform division on this. Here it's a bit 1, and here it is also 1, right? So it can be divided by 1. So 1, 1. I mean, for this can be divided with the quotient 1 here. So when you divide it, the same divisor, you have to write it here. Okay. On this, you perform XOR operation. 1, 1 is 0 when you perform XOR operation. 1, 9, 0, then output will be 1. XOR on 0, 0, it is 0. 0, 0, again it is 0. 0, 1, it is 1. 0, 0, it is 0. 0, 0, again it is 0. Till this part, you have to divide. Okay. After performing division, you will get a reminder here, right? You will get reminder here. I'm going to ignore this 0. Okay, first bit is 0, right? So I'm going to ignore this. Again, this length is shorter than the length of this divisor. That's why what I will do, I'm going to take this 0 here. Okay, now the length of this remainder and this divisor is same. Again, perform division operation. Here the bit is 1, right? So I'm performing division operation by writing 1 at the quotient place, right? This write 1 here. Again, write the divisor value here. Again, perform XOR operation. Here you have to perform XOR operation. Okay. After performing XOR operation, this is the reminder you will get. Okay. Now this 0 I have written here. After performing XOR on 1, 1, again you will get 0. And these two bits performing XOR on 0 and 0, again you will get 0, 0, right? So now, since it is 0 here, how can you divide it? Obviously from 0, right? So 1, at the quotient place, I'm writing 0 and 1, 0, 0, 0. That's what I'm writing here, 0, 0, 0. Okay. And I'm going to take this 0 here. So the divisor and the remainder length should be same. Okay. If it is 0, obviously 0, 1, 0, it's all 0, right? When you multiply it. So it is 0. Then again on this also you perform XOR operation. On this also you perform XOR operation. So this will be the reminder for this division process. Okay. So it's a simple division. I hope you understood whatever I explained till now. Is it clear? Yes?
Yes.
Okay, this will be the new reminder for this division. Okay, so this reminder we represent it using R of X, right? So after that, as I said, R of X, which is nothing but a checksum here. Okay, so after that, according to the algorithm I explained, you have to what? Append for data, this 110. For this, you have to append the checksum, right? You can see, 1 second. Here, I said, right, you have to append the remainder to the data. So till now, we got this remainder value. So now, when you find this checksum, you have to append this checksum to this data. Okay, so again I'm performing XOR operation on this dividend value. Okay, for this dividend value, consider this checksum. Consider this checksum and perform XOR operation on this. Okay, so once you perform XOR operation, this will be the code word that you are supposed to send it to the receiver end. What? It should be sent it to the receiver end. I hope I'm clear, right? So I'll repeat, whatever the checksum that you get after performing division operation here, okay, that should be XORed with the data string. Okay, when you perform the XOR operation, whatever the value that you will get it, that we call it as code word, and that will be sent to the receiver end. Now we'll see what happens at the receiver end. So whatever I explained till now, I just listed it at listed here. So I'll not read it again. Fine. So once the data is received at the receiver end, if the, I mean here, at the receiver end, I mean whatever the code word is received, again this received code should be divided with the same CRC generator. That means this value, this value, okay, this value should be divided with the same polynomial generator. Okay, once it is divided at the receiver end, so whatever the remainder is obtained, that should be checked. If the remainder is 0, then you can say there are no errors. Okay, and the data will be accepted. If the remainder is not equal to 0, then obviously there is errors and retransmission of data is required. So this is what the calculation part at sender side and the receiver side. Now we'll see the output. I mean, first I'll just show you the output, how it will be there. Obviously, we will compile the Java program and we are going to execute the Java code. First, we will ask the user to enter the number of bits. For this program, I've considered 3 as a data bits. Okay. Then you again you will be asking user to enter those 3 data bits. Okay, and you know we are performing operation on XOR operation on binary bits, right? So the data that I'm considering here in the form of binary itself. Since here I have mentioned 3 bits, I'll enter those 3 bits here. Fine. After performing division operation, I mean before performing division operation, we have to append 16 zeros, right? So this is what you will get after appending 16 zeros. Fine. And once this is generated, again the CRC code will be generated. That means what? After performing division operation at the sender side, the final CRC code is obtained. That is, you are appending the checksum with the data string, okay, or data bits. So once this is CRC is generated at the sender side, see this is generated at the sender side. Fine. Now you have to look at the receiver end. Okay, at the receiver end, see here, from here the receiver begins. Fine. Okay, so whatever you have sent the sender data, CRC code, re-enter, enter these bits at your terminal. That is, see, I'm just entering this 1 1 0 0 1 1 0 0 0 0 0 0 0 0 0 1 1 0 0 1 and 0. So whatever the sender sends the data, that same thing I just typed here. Okay, if since both the values matches, it will find out, algorithm will find out there are no errors. We'll see another case. The same thing, number of bits will be 3 and data bits will be 110, and after appending 16 zeros, this will be the data code now. Okay, after performing CRC algorithm at the sender side, you will get this CRC code or code word. Okay, so this, see, I have to retype this at the receiver end. On the terminal, I'm going to retype these bits, but I'll make some changes. See here, 1 1 I've typed as it is. Here there are 0 0, right? But instead of that, what I'll do, I have changed this 0 bit to 1. Okay, and this 1 1 I have written as it is, and few more changes I have made. In the place of 0, I have written it as 1. Okay, and these changes I have made. So if these two values doesn't match, then obviously we can say there is an error. Retransmission of data is required. See, I have changed many bits here. Okay, but even one bit is changed at the receiver end, it will show the error. Okay, so actually I wanted to show the output for this program. in Fedora and Ubuntu, the internet is not working today. But in the next class, I'll show you the output. Okay, I'll show you the execution. So is this clear till now?
Yes, ma'am.
Okay, then we'll move to the coding part. One second. Okay. Is this visible code?
Yes.
Visible? Can you see this code? See this code I have
Yes,
already
ma'am.
sent in the class. Yeah, you can find this program in your classroom as well. Okay. Okay, we'll start the explanation part. The initial required arrays and the variables have declared here. Okay. The first thing you have seen in the output, first we'll ask the user to enter the number of data bits. As per the example, three data bits we entered, right? And that is stored in data variable array here. Okay. And next we ask the user to enter those data bits, wherein in the previous example we entered 110. That is also stored here in the array data of I. Okay, so in data of I, 3 bits are there, that is 110, according to the example that we considered in the slides. Now the divisor bits, we are going to assign it to 17. See, where in the slide I have shown how the generator polynomial is converted into binary strings, right? So where we considered 17 bits. So that is written here. This array, variable is assigned with value 17. Okay. And what are those bits that I have written here and that is placed in divisor array? Okay. The same 17 bits I have written here. And then next part is, now we are finding what is the total length. Either it may be with respect to divisor or the remainder or CRC. Okay, for that we are finding the total length, that is data bits, that is 110, plus divisor bits, that is 17 minus 1. 17 minus 1 is 16, right? 16 plus 3 is 19. So total length will be 19 bits. That length is assigned to div, that is divisor, and the remainder length also it's 19, and CRC will also be the 19 itself. Fine. Now we'll go to the next part, wherein how to generate this CRC code. Okay, or you can say code word. So initially I've just assigned the data of I. So how many bits are there in data of I? We have here 3, right? Initially there are 3 bits here, 110. So that I'm going to assign it to div of I. You can see here the length of div of I is total length, the 19, right? So 19 bits, right? The total length of this array, 19. If you assign data of I to this array, what happens? That 110 will be copied to, assigned to d of array I. Okay. So you have already studied in Java that if partially array is initialized, then the whole array will be initialized to, the other values will be initialized to 0, right? So in the same way here, since data of I assigned it to div of I, right? So the first 3 values, 110 will be placed in this array, and rest all 16 values will be initialized to 0. Okay, according to the array that we use it in the Java where initialization is followed. Okay, now d of I has 110 and then followed by 16 zeros. I hope I am clear to everyone. So that is what it says. If you partially initialize the array, the all other elements in the array will be initialized to 0. Okay, so that property is followed here. Now div has 110, that is data bit, followed by 16 zeros. Fine. So that is what it is displayed here. That is what it is displayed here with the help of system out print. So that is displayed in this d of I. Next, after displaying data bit, where the data string is followed by 16 is displayed, what I'm doing, whatever the bits that are present in div, I'm just placing it to reminder. I'm preserving the values that is present in this array because we have to perform XOR operation to generate the CRC code after the division operation. Okay, that's why I'm just placing the value that is present in this array to reminder array. Okay, just assignment I have done. And next we have I'm calling the divide operation. Okay, so that is wherein you have to perform XOR operation. So we'll directly go to the divide function here. Divide. So for this I'll consider slide itself. 1 second. See, this is the divide function. For this I need this division as well. That's why I've considered this slide. See, divide, where divisor and reminder parameters are passed. I'm using while loop because you have to perform many iterations here. Okay, that's why. So till divisor length, you have to perform the iteration. Let's consider the reminder of current plus I. Please understand this well. Okay, so let me consider the reminder is what here. Reminder is, as of now, it is this one. Sorry, this one. Okay, in the first iteration, that is this one. Now you have to perform reminder of this. You can see this symbol here, which helps you to perform XOR operation. You have to perform XOR operation on this reminder and the divisor. So when you perform divisor operation, you will get some reminder here. So this is, let me take this highlighter. Okay, this is reminder for first iteration, and this will be the divisor. Okay, on these two you have to perform XOR operation. After performing XOR operation, you will get some reminder here. Okay, while explaining in the initial slides, I said I'm going to reject this 0, right? I'm going to reject this 0. So that you have to reject the 0, again consider from the next bit and perform XOR operation. That is what I explained, right? Now you have to ignore the 0, right? For that, I used a variable called current here and initialized to 0. I'm going to check that. Reminder of this will be the reminder now. Reminder of current is equal to 0. Yes, it is equal to 0. And current, that is not equal to reminder length minus 1. Obviously, it is lesser than 1. See, this 0 I have taken from here. Okay, but this length, whatever length is there here, it is lesser than the divisor, right? If both the condition holds good, then increment current plus plus. That means you have to consider from the next bit for the division. Okay, again you can check after increment, again current next bit, that is 1, that is not equal to 0. So this condition fails, right? So when this condition fails, we'll move to the next iteration. That means we will start the division from this bit where 1 is present. Again, perform the remainder with the divisor. So after performing XOR operation, again you will get new remainder. And this goes on till this condition fails. And if remainder dot length minus cur is lesser than the divisor length, then you have to come out. That means here you can see here the values are 0, 0, right? Again, you have to start division from this bit where 1 is present. But the length of this remainder is lesser than the divisor length. So you can't divide it anymore. At that point, you have to come out of this while loop. Okay. So after coming out, you are going to return the remainder. Remainder, which is nothing but this value. Okay. So I hope I'm clear with this function, division function. Is it clear? Yes?
Yes, ma'am.
Yes, ma'am.
Okay, thank you. 1 second. So after this, 1 second. After this division, as I said, you are going to return the remainder. Okay, that yeah, here the remainder will be written. After this, you have to perform the XOR operation between divisor and the remainder, where you can get the CRC code. That is 1 second. Here. See, after returning remainder, you have to perform the XOR operation on divisor and the remainder. That is, sorry, here, whatever the value that we have assigned here for this data string and the remainder. When you perform XOR operation, you will get the CRC code. That is what I'm doing here. Divisor and the remainder. When you perform XOR operation, you will be ended with CRC code, which is nothing but this one. So this is the CRC code which is generated at the sender side. Now what you have to do, you have to check whether the CRC code after performing division, will it give the remainder as 0 or 1? That you have to check at the receiver end. That is, yeah. So that is what is displayed with the help of this printout statement. And then here, I'm asking the user to enter that CRC code, enter the CRC code. So user will enter the received CRC code here. Okay. And once it is received, okay, you are going to perform the divide operation, same as the previous one, whatever I explained. After performing division operation, it will return the remainder. Okay. Once it returns the remainder, you will check whether that remainder is not equal to 0. If it is not equal to 0, obviously you will say it has error. I mean, the received data has error. If not, if you get 0, then you will say no error and retransmission is not required. And at the end, I've just printed thank you statement. That's it. This is very simpler one, but you should understand